Hi, I'm Luke Moore from Side Effect Software. I'm a developer here, and I've been working on the Python integration in Houdini for the last few years. So I'm going to talk about some tips and tricks, and then later on in the second half of this video, I'll talk about what's new in Houdini 11. So Python's something we've been using internally a lot more and more. So not only is it something that you can use yourself when you're using Houdini, but Houdini itself is being written more and more in Python. So some of the big items you might notice, the shelf tools that come with Houdini are all written in Python. But some stuff that you might not even know is written in Python is also. So things like our new cloud support to render using Amazon's EC2 cloud, that's entirely written in Python. So it speaks to the power of Python itself and to the level of integration in Houdini of Python. Our HQ, our job server to send things off to the render farm, is also all written in Python. Even Houdini's help server that runs in a separate thread in the background and serves up the help for Houdini's in-browser help, that's all written in Python. And then lots of smaller things from menu items like the motion effects menu to the downloader for the shelf and color scheme, things like generating icon caches, all of that's written in Python. So more and more of Houdini is being written in Python itself. So I want to talk some about when you should use Python and try and mention when it's a better idea not to use it. So the best places to use Python are when you can't already do it in Houdini. When there's no place with nodes or vex and vops to do exactly what you want, Python lets you have a totally free-form way of writing a little bit of code to do something. But if you can do it in Houdini, it's often easier for people to understand. It's often faster if you can do it with nodes or you can do it with vex. So I'll try and hint at when it's a good time to use Python and when it's not. So I just want to pull up Houdini and I'll do a gentle introduction at first of how just some basic scripting with interacting with nodes and parameters, and then as we go on I'll get into more and more complex stuff. So if I switch to Houdini, I've started up the Python shell here, so if you want to start a new one you can just right click on a tab and you can change it to Python shell, or if you want to start a new tab you can say new pane tab type Python shell. You can also get a floating one by doing Windows Python shell there, and the shortcut for that is Alt-Shift-P. So that'll give us the same thing. So once I have the shell open, I can use it just like a calculator. So I can type in an expression and it spits me back the result. So if you don't use Python for anything else, at the very least it's a handy calculator sitting there for you. But the nice thing is we can script all kinds of different pieces of Houdini with it. So if I want to change something on a node, like get its name or find out the children that are inside of it, I can do that very easily. So the easiest way to get started is just to drag things into the Python shell. So I'll just grab this geometry node here that I've created, and when I put it down in the shell, it creates the code that will give me back the Python equivalent of that node. So when I pressed enter, I can press the up arrow and rerun it again. I'm calling who.node. So who is the general module in Python that contains a set of functions. So I'm calling the node function on the who module, and I'm passing in a string which contains the path to the node. So here I'm saying give me the Python object corresponding to obj/go1, so this node, and then it spits me back this. It's the string representation of the result. So it's telling me that it's an object node, the type is geometry, and here's its location. So I'll just assign that off into a variable. So I'll call it n, and now I can use n to refer to this geometry object. So if I say n dot, it gives me this nice pop-up telling me all the different methods that I can call on it. So these are the operations I can perform on that node. So if I want to find out its name, there's a name method. When I type the open parenthesis, it gives me the help for that method. So here the help is pretty simple, it just gives me back the name. So if I close parenthesis to pass in no parameters, it tells me back the name is Go1. Similarly, I can call n.path, and it gives me back a string with the full path to the node. If I dive inside, I'll see that there's just the file object now. I'll maybe create a box, a sphere, and just merge them together just so I have some more nodes inside this geometry object. I'll just get rid of the file. So now I've got 3 nodes inside of it. So n is still my object node at Go1, and I can ask for its children. So n.children gives me back a tuple of nodes. So in Python, a tuple is just a sequence of them. So here I get multiple node objects. So it's telling me I've got a sop node of type box for box 1, sop node of type sphere for sphere 1, and then my merge for merge 1. So if I want to find out the nodes that are inside of another node, it's very easy. I can just say .children, and it spits me back a tuple of them. And then I can assign that off to another variable. So I'll call it t for tuple. And then I can use Python's square bracket operator like that. So t square bracket 0 to get the first element, 1 to get the second, 2 to get the third. So it's all base 0. I can loop through them. So if I want to do something for each of them, so I can in Python say for c in n.children, and then a colon. So that'll loop through each of the different children and all the different Python objects in that tuple and assign those to a variable called c. So if I hit tab, I can now, in the contents of my for loop, do something. So I'll say c dot, maybe I'll print out the name. So it loops through the 3 Python objects that are children of obj01, so the 3 different SOPs. For each of those, it assigns them to a variable called c, and then I can print out the name of the 3 different SOPs. For parameters, it's very similar. So if maybe I'll go back up to my geometry object and just select it so we can see its parameters. If I want to set or grab the translate parameter, let's say the tx, I just say n.parm, and the parm method takes in the name of the parameter that I want. So this will give me the tx parameter on the geo1 object, and that gives me a parm object. So we saw there's a node object that corresponds to nodes. There are parm objects that correspond to parms. And on the result of that, so I can assign that off to p for the parameter. And now I can look at the methods for it. So I can say p.eval and open and close parenthesis. So it gives me back the current value of that parameter. So I can change the parameter value, hit the up arrow to rerun that, and it tells me the new value. If I want to set it, it's very similar. I say p.set value. Sorry, p.set. And then I pass in the value that I want to set in an optional language if I've got an expression. So if I want to set it to 0.5, I say p.set, passing in 0.5, and we'll see that the parameter changed. If I change that to 1.5, the parameter is updated. So it's fairly intuitive. The objects in Python correspond pretty directly to the objects in Houdini. So there are nodes, there are pane tabs, there are viewers, network editors, and so on. If you want to start exploring it, the easiest way is to, like we've been doing, get an object and assign that off to a variable, so n and p in our case, and then once you have that, you can say dot to get the list of methods. I can also say dir, passing in n, so dir of n gives me back a Python list, in this case, of strings. So it just gives me back the contents of that menu, the pop-up menu. So here I could see add event callback, add node group, add spare parm tuple. Those are all the things that show up when I start typing. So n dot, and here they are there. If you want help on a particular thing, so I can say help on n dot parm, and it gives me back the help for the parm method. So here I pass in the parameter path, and it gives me back a who.parm object, or none if it doesn't find it. So I can use the Python shell to explore things, and also in the help I can find all that documentation. So if I start up the Houdini help, once that comes up, I can go to the home section. Let's try that again. So if I start up Houdini's help, I can navigate down to the Houdini object model section. So that's the Python library. And then here, there's at the very bottom, there's the reference section called Who, and there are a bunch of topics just if you're getting started with HOM. There's the HOM cookbook, which has a whole bunch of examples. So we'll look at some of those later on. And then just some tips and tricks in here. So if I go to the reference section, here's where I can find all the different classes, and I can look up node. There are a bunch of different node things. Here's the node class. And then in it here are all the different methods. So all the information I can find in the Python shell, or I can look it up in the Houdini help also. Okay, so let's see how we can build a little function. So a function is a way I can take a little bit of Python code and kind of wrap it up into one little snippet of code, and then I can call that. So if I've got something that I'm doing over and over again, I can wrap that up into a little package and then call that. So let's have something that maybe lists all the different children of a node. So I'll just create the name of the function. So I put the def keyword in front to say I'm defining a new function. I give the function a name. I give it any parameters that it takes. So here we're going to pass in the node, and it'll spit us back all the children of that node plus all the different children that are inside that, and recursively give us the whole set of nodes inside one particular one. So if I was to call this on the /obj node, it would give me all the different geometry objects, and then for each geometry object, all the different nodes inside of that. For any subnets in there, all the nodes inside, and so on. Okay. So we'll grab the immediate children. So maybe we'll create a result. So for C in node.children, like we saw, we'll add that to the result. So here result is a Python list. That's what those square brackets do. So I'm creating an empty list, and then I'm going to call the append method to add that into the list. So I'll loop through all the node's children, add in the child itself, and then let's also add in the children of that particular node. Okay, so we'll loop through all the children, add that child, and then I'll add all the children of that child into the result. And then the return statement will return the result list that we've created. So let's try that. So children of node, passing in n. If I spell it right. So n, again, remember, was our obj-geo1, and it tells us those three SOPs. So our box, sphere, and merge. If I was to say children of node, passing in who.node slash, or maybe slash obj, to give us the obj node, we'll see we've got geo, and then because box 1 is inside geo1, it shows up, and so on. And finally we can do slash, so we get the slash obj node, slash obj slash geo1, geo1 box 1, geo1 sphere 1, and so on, and slash ch slash shop, and so on. So we could, in theory, write complete programs just using the Python shell. So I can enter in a complete function here, I can enter in another one and enter in something that calls it, but it's pretty tricky if you make a mistake. You have to go back and change every single line. So there are a number of places in Houdini where we can actually store Python code. So I just want to show you that. The first that I'll show you is the Python source editor, which stores things in the who.session module. So this is a piece of Python code that gets stored with the HIP file. So whenever you save the HIP file out and load it back in, this gets restored. And here's where we can put arbitrary functions or constants, whatever bits of Python code that we want to call from this particular HIP file. So I'll just grab this, copy it, and paste it in here with Control V. Get rid of this. Okay, and then I hit apply. So now this is saved off. I can go back and really easily edit it. And if I want to call this function now, I use the who.session prefix. So I say who.session. That's to remind you that it's saved with the HIP file. .children of node, and then n. So instead of just calling the function children of node, I moved it into here, and it's just prefended with who.session. So I could create another one. Function foo just returns the integer 3. It would be who.session.foo. I can have as many different functions in here as I want. So that's how we can have something get stored with the HIP file. If you want to have some code that gets stored with your desktop, so your shelf, that's also very easy. So if I scroll over, I'll just find a free spot on the shelf. Maybe close up this Python source editor. So again, that's Windows Python source editor to edit who.session. I'll say new tool on the shelf. So I right click and say new tool, and then give the tool a name and a label. And then when I come over to the script tab, here's where I can put my code. So I can put something simple that says print something out to the Python shell. So now when I hit apply, there's my new tool called hello. When I click on that, you'll see it prints out hello to the Python shell. So that's pretty simple. Doesn't do a whole lot, but from here we can access the current scene viewer pane. We can use it to create a node. We can select something in the network pane. So all of the stuff that you do right now when you click on these tools is all running Python code that's doing exactly that. So let's see how we can grab maybe first let's start off and print off a message to the display instead of the Python shell. So there's a who.ui module which lets us interact with Houdini's interface. UI is short for user interface. So who.ui.displayMessage pops up a little message dialog. If I look at the help, you can take a bunch of parameters so I can customize which buttons are on it, which icon, and so on. But if I just give it a single string, this is the message that gets displayed. So I'll hit apply. Now I'm going to hit hello. Accept. Try that again. There. Now I get this dialog popping up saying hello. If I want to access the pane tab, like a network editor say, also use who.ui, so I can say who.ui.panetab of type. And then if I wait for the help, it tells me that it takes in a parameter called type, and then an index in case there are more pane tabs of that type. So type is a who.panetab type enumerated value. So I can say who.panetab type dot network editor. Control tab will complete in here, and you can hit tab to complete in the network shell, or the Python shell that is. So who.panetab of type, who.panetab type.network editor will give me back a network editor pane. So I'll assign that off to a variable called p. And then if I want to find out what I can do with a network editor pane, there are a couple of tricks. So one is to know what I'm dealing with. So panetab of type, if I check the help again, panetab of type, it tells me it returns me a who.panetab. And depending on the actual type, it'll be a subclass of that. So it happens that it returns me who.networkEditor. So if I look at the network editor class and hit dot, then I can see the methods. So that's one trick, is to, if you want to find out what methods of an object you have, you can look at the class and see its methods, and then use that to make your calls. So network editor, it's got this select position method, and then it'll prompt in the network pane where you want to put down a node. So I know that P is a network editor, so I can just say p.selectPosition, and maybe I'll print out the result. So let's try that. So I click on the tool. It's now prompting me in the network editor with the little box that we're used to when we hit the tab menu and pick a tool. And when I click, it prints out in the shell the location in the network pane where I've clicked. So if I try that again and click a different location, I get a different location printed here. So I could use that to set the position of a node, for example. So I could say, if I grab my sphere, I'll call that n dot set position takes in a vector 2. So I could pass in 18245.0.388.265, for example, to move it to where I'd clicked. So I could wire those together. I could create a new node and then position it at that location. So P is my network editor tab. I'll ask its current location, so the network that it's currently inside, and ask that node to create a new node. So create another box node, and then I'll assign that to the variable new node. So we'll prompt for the position, create a new node, and then set that new node's position to the one that was selected. I'll assign that into variable position. Okay, so P is our network editor pane. Position is the position that we click on in the network editor. We'll create a new node by asking for the pane's current node, so the PWD of that pane, present working directory, to create a new node, and we'll create a box inside of it, and then we'll set the position of that box to where we clicked. So let's try that. Click on hello, prompts us in the network editor, and then the box gets positioned there, or approximately there. We should, to do things right, account for the width and height of the box and center it on that location. So that's approximately what all these shelf tools are doing. And if I want to see exactly what it's doing, I can just right click on any tool, pick edit tool, and then see the code. And there's not very much code because a lot of it is stored away in these common modules. So for example, SOP tool utils has a function in it called generic tool that gets passed in all the different parameters when you click on it, and then it does all the work. So most of the tools up here are very short, and they're calling into other code to do the work. So if you want to see exactly what's going on, you can look in HFS Houdini scripts Python. If you're using Houdini 10, in Houdini 11 it's now in HFS Houdini Python 2.5 libs to see that. So let's pull that up just to get a sense of where that is. So program files, side effect software, Houdini 11, Houdini, Python 2.6 libs, and here are all the different .py files. So if I look for SOP tool utils, there it is there, and then I can open that up with WordPad in this case. So you can use your favorite editor. And here if I look for generic tool util, generic tool that is, there are a bunch of different places where it's called, but there it is. There's the function that gets called. So this is what happens when you call generic tool, and it calls a bunch of other things. There's a module called tool utils also in the same directory, and it passes the parameters on. So I definitely don't have time in this video to go into the details of how to create a shelf tool. I just want to get you pointed in the right direction. If you are interested, here are the locations to start digging around, to look in the code and see exactly what's going on. Okay. So we've seen how we can store something with the shelf, or with the HIP file. This is how we can store it with the shelf very easily by editing some script there. I'd like to look at some parameters and show how we can put some Python scripts inside parameters. So let's go back up to our geometry object. And if I translate it now, it shows me the value. I want to put a simple expression in there. So in HScript, if I wanted to make the translation value be the frame divided by 10, for example, I just say $f divided by 10. And now as I scrub through, it translates along x accordingly. So the equivalent in Python is frame, the frame function, who.frame, divided by 10. And if I type that in, I get an error, because it's trying to interpret my Python expression as an HScript expression. So it's trying to run HScript with this, and it gives me an error that HScript can't evaluate that expression. So I need to tell Houdini that it's a Python expression. So the easiest way I can do that is to right-click and say expression change language to Python, once I already have an expression. And now when I step through, it updates accordingly. And you'll see that it's now turned to red, and that's just to indicate that the node's default language is different from this particular expression's language. So this drop down here where it says H is the node's default language. And what that means is that the next expression that I create will be in that language. So if I change it from HScript to Python, and now start typing in a new field where there isn't already an expression, rotate maybe by frame times 5, it means that that expression is now a Python expression, because there wasn't one there before, and I created a new one. So now if I play it, or if I scrub through, we can see it's rotating on X. When I change it back to HScript, and I type in a new one, now it'll be based off the HScript expression. So if I put an HScript expression in TY, it's going to default to interpreting it as HScript because it's set to H. And the ones that were in Python turn back to pink, just to let you know that they're different from the node's default. So if I change the node's default now to Python, the HScript expression's in pink, and the Python ones are in green. So that's all it's meaning when you see pink. It's not an error, just giving you a hint that it doesn't match the node's expression. So just a couple things. Who.frame is the equivalent of $f, but that's a little bit much to type to say who dot all the time. So one of the things you can do inside Python expressions is to drop the who dot prefix. So any place I would call node or who dot node, I could just say node in a Python expression. If I was to say who dot frame normally, I can just say frame and so on. So I can just drop that who dot prefix because Houdini runs in Python. It says from who import star inside the context of these Python expressions. So in general, it's nice to have these namespaces where we know where these names are coming from. So if I type in frame, it's nice to know that it's coming from who. So I would normally, in a script, say who.frame. But for the interest of brevity in Python expressions, you can drop that who prefix. So frame is equivalent of frame. There's time, which is the equivalent of who.time, or sorry, equivalent of $t in HScript, and so on. One of the most important ones is who.lvar, which is the local variable equivalent, where I give in the name of a local variable. So this lvar of the string pt is the equivalent of $pt, and so on. So if I was to dive into a point sop, for example, maybe we'll apply a point sop to this box. And if I set the position, the default is $tx, so if I want to change that to a Python expression, it would be lvar tx is the direct equivalent to $tx. There's also cur point, so the HScript the Python point object corresponding to that, and that's actually a who.point object. And from that point, we can grab the number, we can grab the position, and so on. So the actual true Python equivalent of $tx is cur point, or pwd rather, cur point. So the current node's current point position. So pwd is the current node that contains the parameter. It gives us back a sop node that we can ask for its current point, and then from that point we can ask for its position. So that's the exact equivalent. You can shorten that to lvar of $tx if you're used to the HScript expressions. One nice thing in Python expressions we can do is if we want to create something that's really big, we don't have to worry about trying to cram it in on one line. So if I press Alt-E, I can bring up the multi-line editor. And the rule of thumb is if it's a single line, it's just an expression, so something that evaluates to a value. If I put in multiple lines here, then it becomes the body of a Python function. So I can put logic in there to do if statements and for loops and so on. So if I want to say, if this is point number 1, so pwd.curPoint, maybe I'll say that off to a variable. So point is pwd.curPoint. If point.number is the first one, then we'll do something different. So we'll return 1.0 or maybe 2.0. Otherwise, we'll just return its current position. So we can create these multi-line expressions that are the bodies of a Python function, and we return the values in those functions. So here the first point gets moved over as if I change this value from 2 to 10, we'll see that first point gets moved over even further. So just a toy example to show how you can create multi-line expressions. And the rule is that if it's multi-lines, that it's the body of a Python function. Okay. And then it shows up here with these little breaks to indicate that it's the the end of the line. Okay, so just to summarize, let's go through what we've seen. Python shell is great to experiment. We can use the pop-up help. If we want to find out the value of an expression, it's easy to store it off into a variable. So for example, I could have written who.node /obj dot parm tx, or sorry, obj01 dot parm.tx. The problem is I don't get any pop-up help after I've typed in who.node. So /obj/go1 dot, and I don't get pop-up help. So the easy way to get that help is to store that off into a variable. Once I have it in a variable, it knows what type it is, so I can do the pop-up help. We can inspect the classes to get a list of methods. So if I know that I've got a node object and I'm writing a script, I can just say who.N_node to look at the class and get a list of the methods there. We can use Python's built-in functions dir and help to get the directory of the methods on a node or on an object, and the help to get a help for a particular method. And then I can drag a node into the Python shell. I can also drag a parameter into the Python shell. So if I want to get this parameter on the point stop, I can just drag that in, and it says who.parm of tx. If I drag in the label, it gives me a parm tuple, which is like a parm except it includes all three values. So here, if I do a help on it, it tells me that the parameters inside that are tx, ty, and tz. So the parm tuple is t, and it contains the three values. So I can evaluate that parm tuple, and it gives me back those three components. There's a bunch of things you can drag. You can drag shelf tools and pane tabs also. Oops. So there's a bunch of different things that we can drag into Python shells. One thing I should mention in shelf tools is that I can see what information is passed in with a special variable called kwrgs. So that's something that's used throughout Houdini. So let's just restart to get a clean session. If I go back to my tool and pull up the Python shell, so here's my tool that I created earlier. I'll get rid of what's here, and I'll just print out the contents of the kwrgs variable. So now if I click on it, it gives me this, and it's a Python dictionary that contains a bunch of different parameters that are available to your shelf tool. So the branch is, if you're invoking the tool from the network or from the tab menu, it'll tell you whether it was right-clicked, whether you invoked it by right-clicking on an output or not. Input index and autoplace, those are all things for the network editor. Whether you alt-clicked on it, so now if I alt-click and press hello up here, alt-click is true, versus before it was false. Control-click, shift-click is in there too. Whether it was invoked from a viewport or not, so if I said tab and I made my tool available in the viewport, let me just turn that on. So I'll make it available in networks and in the viewport. So I can say tab hello, and now it tells me that I've invoked the tool from that geometry viewport. If I do it again down here from the network editor, it tells me that I've invoked it from the pane network editor, pane tab 7. So lots of different information is passed in this kwrgs variable to let you decide where the tool was invoked from, and so on. And we'll see that it's used throughout Houdini, this kwrgs variable, to tell you extra information that gets passed into a piece of Python script. So seen it in shelf tools, we'll soon see it in asset event handlers, in parameter change callbacks for digital assets, and then in the Python module itself, which we'll see for digital assets. I briefly mentioned that there are these star tool utils, so SOP tool utils, there are some object tool utils functions or Python modules, and there's a generic tool function in there that does most of the work of a shelf tool for you. And then just one tip, if you want to exit a shelf tool early, you use sys.exit, which is a little bit strange because normally sys.exit exits your Python program That's just the way to exit from a Python script or Python shelf tool in Houdini. One neat trick you can do too is you can have shelf tools that don't show up in the shelf or in the network pane or in the viewport pane, and you can have them bound to a particular hotkey. So you can make it so it doesn't show up in anywhere else, but is only bound to that hotkey, and basically lets you bind a hotkey to run some arbitrary piece of Python code. So that can be handy. Python expressions, we saw a simple example, and there's that simple rule to remember. If it's a single line, it's an expression. If it contains multiple lines, it's the body of a Python function. Just have a look at some string parameters too, because they're a little bit trickier to set up. So let me create a font sop. I'm just going to put an expression in here. So I want to keyframe the text part of it. So I left click on it to let me edit it as an expression. I'll alt left click now to create a keyframe, and by default it's an HScript keyframe because it was in HScript. So now I can say expression, change language to Python, and now I can edit it as a Python expression. So it's going to give me an error because that's not a valid Python expression. So I'll just create a simple string, and that is a valid Python expression. If I want to print out the current frame, I could do something like frame colon %s modulo frame. Or if I want to round that to an integer, I can round down like this. Okay, and this is Python's standard formatting operator, so %s gets replaced with the thing on the right of the modulo operator. So I grab the frame as a floating point number, convert it to an integer, and then put that into the string there. So if I want to do something a little more complex, like grab the current time and display that in minute, minute, second, second notation, I could do something like %o2s, or maybe %o2d, colon %o2d. So I'll have two places where they're padded with zeros. I'm going to grab a decimal representation of it. And for the second part, for the seconds, I'll grab one part after the decimal place and have 3 digits in total and pad that with zeros. So this is documented in the Python standard stuff. It's C-style printf notation. Okay, so here I've got padded with zeros, 2 decimal places, and whatever gets passed in gets converted to an integer. So I pass in 1.5, it gets converted to the integer 1, and padded with an extra 0 out front. Here I'm saying padded with zeros out front, convert it to 4 places, which will include this decimal point. So 0, 1, 0.2 is 4 different characters. Point, and then after the decimal place have one decimal, or one character. So if I pass in 1.25, it rounds that up to 1.3, and then pads that with a 0 out front to give me 4 characters in total. So I can do a sort of time code this way. So if I take the current time, for example, divide that by 60 to get the number of seconds, or number of minutes, and then the current time modulo 60 to get the number of seconds, and now I've got a simple time code. So I can step through the play bar and see it increment from there. Okay. So that's creating a string parameter. Just have to remember to add the keyframe and then change the language to Python, and you can start editing it. Just note that if I have a string without a channel, it doesn't actually contain a true keyframe. So if I put down, for example, a file sop, and I was to say, or maybe a font sop's fine. So here where it says frame colon $f, it's not an actual keyframe. So this is just a string that gets expanded, and Houdini replaces all the $sign variables with their contents, replaces anything in backticks with the contents of that HScript expression. So this is HScript expression-like, but not a true expression. So just one thing to note. I can't put a Python expression in there until I actually have a true keyframe. I mentioned that we can drop the who dot prefix in parameter expressions because Houdini's doing this Python expression or Python statement to say from who import star to basically bring in all the names in that who module into the context for the expression evaluation. There's a who.expression globals dictionary. So if I call that function, it gives me back this big output because it's a big dictionary with all the different names corresponding to what's already in that context. So these are all the names that are available without typing who dot, so the vertex class and so on. If I want to add my own function in there, I can modify this dictionary. So for example, if I want to create a function called foo, again that returns 3, I can say who.expression globals and set the foo entry in the dictionary to be my foo function. Now I can just call foo from here if I have a Python expression. And we'll see it evaluates to 3. So it's nice if you've got a library of your own functions that you want to call from Python expressions. You can set those up and have Houdini load them in automatically, and then use who.expression globals to inject them into this namespace where they can be called from your Python functions. So if there's a math function, for example, that's missing, so Houdini automatically also imports the sign functions, math.sign as just sign. But if there's some other one like that that's missing that you would like, it's really easy to add that in. Alright, so let's have a look at digital assets and show how we can add Python code to them. So I'll take this font swap that I've created. I'll go up and I'll create a digital asset out of this geometry object. So I'll collapse this down into a subnetwork, so Shift C or find the collapse entry, and then from the subnet I'll create a digital asset. So I'll choose create digital asset, which I know is just off screen. Call this timecode. Alright. And then we'll add a parameter for the time that we want to be displayed. So we'll create a single float parameter. This will be our time. I'll just hit apply there and dive inside. So now my Python font swap, I don't want to call who.time. I want to grab the time inside that digital asset. So from here, I'm inside font1. So one level up is geo1, 2 levels up is subnet1. So I want to do dot dot slash time. And the function that I want to call there is, I could do who.parm, or I don't need the who part, so I could just say parm dot time dot eval. That's a bit much to type. In Python we can just say ch, just like you would in HScript. So ch of dot time to grab that parameter, divide that by 60, and then do the same thing to take the time modulo 60. Okay. So have a look and see the error. Oh yeah. So I'll grab there we go. Grab the time parameter from 2 levels up, divide that by 60 to get the number of minutes. Same thing to get modulo 60 to get the number of seconds. And then we'll format that exactly as we did. So now if I go up a couple of levels to my digital asset and scroll down to the bottom, here's my time parameter. And as I scrub that, I can see it updating there. Okay, so that's there's no extra Python code. We just modified our existing Python expression to refer to a different location. So now let's see how we can add code to this digital asset. So let's make it so when you put down a new instance of the asset that it changes the color of the node, for example. So I'll bring up type properties. And now if I go to the scripts section, and on the event handler section I look for the scripts. These are all the different event handlers that get called when I do something with the node. So before the node gets, before any instance the node gets created, after it's been loaded, I can put in this before first create, where it'll run a piece of code to do some initialization. Uncreated is when my node first gets created. Unloaded is when it gets installed, unupdated, and so on. So let's create an uncreated section. And now I can change this edit as to Python. So it'll run a Python script. And let's print out kwrx just like we did in the Python shelf example. So let's save that off. So if I say tab, digital assets, timecode, I now get something printed in the Python shell. So as expected, whenever we created a new instance, it runs this code. So I can do it again and watch the Python shell. We'll see it print something out. This is another dictionary. So kwrx is always a dictionary. And it's got a node key in it, which tells us the node that just got created. And it's got a type, which is the node type corresponding to that node. So now, from the node object, we can set the color. So let's look at the node class. Have a look at the set color method. It takes in a color object. And we can create a color object with who.color, passing in an RGB tuple. So let's try that. Let's create a red color. So an RGB of 100 in this case. And then we'll call set color on that from the subnet. So I'll save that off into variable C, grab this subnet, call set color on it, pass in C. And as we wanted, it turned red. So let's do something from the digital asset so that whenever it runs the uncreated part, that it calls that. So remember, kwrx is the dictionary. kwrx passing in the key node with the square brackets and then the string singular double quotes to grab the node key out of it. So this is the node that just got created. So from that node we can say .setColor and then pass in the color that we want. So create that who.color again, passing in a tuple. And let's change it to, I don't know, something bluish. Okay, so let's give that a try. Save that off. Tab, digital assets, timecode, and now it's that bluish color. Okay, so that's how we can put something into an event handler. I'll pull up type properties again. It's nice though to kind of put all of our Python code in one place for a digital asset. So instead of having to scatter it across the different event handlers and scattering across different parameters, as we'll see how we can add code to them, let's put it in one central location for the node, or for that node type. So for digital assets, we have this special section called a Python module. So it's all the different code that lives with this digital asset. And let's create a function here called onCreated. We could name it anything, but let's try and keep the name similar to the section. We'll pass in the node that was just created, and then we'll do what we just did. So node.setColor, and then I'll grab the code to create that color. So let's have a look at the uncreated script. Copy that out. Okay. So this will be the function that we want to call to do all our initialization work. And then from our uncreated section now, we're just going to call that function. So the way we can get at it is we grab the node, and there's an HDA module method on the node to give us back the contents of this Python module. So it's, if I have a node that's a digital asset, I call .hda module, that gives me back a Python module corresponding to whatever's in here. So now from that Python module, I can just call the functions inside of it. So I created an onCreated function inside Python module. So I can say node.hda module.onCreated, and I need to pass in the node that was created. So in this case, the kwrx node contains that. Okay, so I'll save that off. Let's create a new instance. There we go. So change the color so everything's working. We can have a look at the code again. So kwrx node, the thing that was just created, grab its HDA module, call the onCreated function inside that module, and pass in the node that was just created. And here's that function. Takes in the node that was just created and sets the color to a particular color that we set. Okay, so that's the kind of paradigm that we'll see. We'll create a little function in this Python module section, and then invoke that from other different parts of Houdini. Okay, so now let's see how we can do something from a parameter. So I'll pull up the type properties again and switch to the parameters interface, and I'll add a button. So I'll drag over a button parameter. The code that gets run when you click on the button is here, so we can change the callback script in the script language, so change the script language to Python. And here I can just enter in a single expression. So to grab the, let's try this, print KWArgs. And when I click on press me, it runs, and here's the contents of the KWArgs dictionary corresponding to what happens when you press the button. So there's a node entry, there's a script value 0 and script value 1, and a script value that correspond to some old HScript variables that have been around. The most interesting things though here are the parm and the node. So we can figure out which parm was pressed on and which node. So let's pass in the parm, and let's pass that into a function in our HDA module section. So to get the Python module section, we need the node. So KWArgs node gives us that. .hda module gives us the module. And let's call a function called onPressed, say. So we'll create one called onPressed, and we'll pass in the parameter, which we could do something with. Okay. Oops. So here it is in Notepad, KWArgs node.hda module.onPressed, so that's the function we're about to write now, passing in the parameter that was clicked on. So we could have, if we wanted, one function handle clicks from multiple different parameters, or changes on multiple parameters too. Okay, so now let's go back to the code tab, or to the scripts tab, to the Python module section, create onPressed, passing in the parm. Let's print out let's grab parm.path, which will be the path to the parameter, and build a string out of that. So say you pressed that. And then we'll just display that message. So we'll call who.ui.displayMessage again. Okay, so we'll just pop up a dialog saying the path to the button that they pressed. So let's accept that and try that out. Okay, so now passed in the path, passed in the parm object. The path to that parm object is obj timecode 1 button, and it pops up a dialog saying that we clicked on it. Just want to show an example if I make a mistake. So let's take out the K in KWArgs and just have a look at the errors that we get. Oops. Oh, that was the uncreated. I want to change this one. Alright, so let's take out the K there, just so you can get a sense of what happens if you make an error. So we get this error running callback, and it gives us a Python stack trace. If it comes from an actual Python file, a .py file, it's more useful because it'll say the actual file name, and that line number becomes very useful. Here it doesn't say much, it's just saying in module line 1, so it corresponds to line 1 of that button parameter callback script. So we can fix it there, pull up type properties, go back to the button, change that back to OK. Let me make a mistake inside the Python module section so you can see what it looks like there too. So maybe drop the H from here. Okay, so now here's another one saying line 1 called something else, so that was the single callback for that button press. Here's the other thing that gets called, so it's telling this in opdef, the timecode asset in the Python module section, that at line 5 in onPressed, the function onPressed, here's the error. So the global name OU, because I took out the H, is not defined. So this is a lot more useful. It tells us where the error is occurring, so it's in that Python module section, and most importantly, that's on line 5. So if I pull this back up, I can go to the Python module section. I can hit Control G to jump to line number 5, there's also a shortcut button up here. One of these guys. I added this, so I should know where it is. Yeah, there it is. So I can type in line 5 to go directly to it. So that's the easiest way to navigate around and find your errors, is to use Control-G and jump to it, or just to look at the bottom here where it tells you the current line that you're on. This updates as you move the cursor around. Okay, so let's fix that. So that's the paradigm we'll see. We'll keep putting more and more code into the digital asset and then invoke that from event handlers or from parameters. The nice thing is that because it's stored with the digital asset, it'll work across different HIP files. So it's not like who.session where it's stuck in that HIP file. It's not tied to your shelf, which is potentially tied to someone's particular desktop setup. It truly lives with the asset itself. Just to note, different event handlers had different things in that KWRX dictionary. So we saw the onCreated one that had node and type. Most of them have node, so onDeleted, anything where it actually involves a node. If the node gets updated, onUpdated takes it in. If you rewire it or change the name of the node, they get passed in the node. But other different handlers also get passed in different parameters. So for example, after you delete the last instance of that node type, it just gets passed in a type parameter. Oops. Come back to that page. Okay. So the Python module is a place for that asset to store its own code. So it's a common location for all those event handlers, parameter expressions, and so on. You can put functions in there, as we've seen. You can also put constants. You can put your own Python classes. All of that you can instance from the digital asset, either with an instance of the digital asset or from the node type. So I could access the Python module section from an asset that doesn't have a node created yet. I can just grab the definition for that asset. Just a tip here too, if Houdini has this disable when syntax to disable a parameter. So I can say disable it when the type is 1 and the count is greater than 10, or when the tolerance is less than 0. So it's kind of a limited syntax. You can do ands and ors, and you can do simple comparisons, but you can't do a lot of complicated logic. For example, you can't query a database to see the value of something. So one trick you can do is to create a Python parameter, put an expression in that parameter that queries the database or does whatever complicated logic, and then from another parameter set the disable when based on the contents of your Python expression parameter. And then you can hide that Python expression parameter with the complexing. So you're putting the disable when in the one that you want to hide, having it reference this other one that contains a Python expression, and then putting the complicated expression in there. And just to note that you can't have Python default expressions. They have to be HScript default expressions right now in the type properties dialog. So you can use the HScript Python exprf to evaluate a Python expression as a float. So just a note if you do try and do that. Let's have a quick look at menu parameters. So if I pull up type properties again, I can add a menu. So I'll add an ordered menu here. I'll just call it menu. If I go to the menu tab, I can say menu script, and then I can change the language to Python. So now this is either an expression or the body of a Python function that evaluates to the contents of a menu script. So it has to return a Python sequence where the first element, or the even elements of the sequence, I guess, are the internal names, and the odd ones are the labels. So for example, if I return this, and hit apply, here I get two things. So the external labels are XXX and YYY. The internal names, if I evaluate that as a string, sorry. Oh, yeah. The internal names are 1 and 2. And just as a limitation in Houdini in general, where if you try and evaluate the contents of a parameter that's defined by a menu script, you can't get the name. It's always 0 or 1. Okay. So this is the internal name, that's the label, this is the internal name, and that's the label. So if we wanted to do that more dynamically and have something that generates a menu on the fly, we can again use the Python module section. So I can say kwrargs node.hda module dot, and then I'll say menu contents. That'll be the function we'll create. Oh yeah. In this case, there is no kwrargs. So I have to do who.pwd.hda module. So the current node that's had its button pressed and asked for its HDA module. And then over here in the Python module, create a menu contents function that'll return that same string. So 1, 6. So here I could do something more complicated, dynamically build up a menu of things, and so on. So there it is there. So this could be based on the contents of the node, for example, or the settings of other parameters, and so on. Okay.